an exercise within the Machine Learning Foundations for Product Managers course to take a data set which provides the ambient temperature, the ambient pressure, the relative humidity, and the vacuum to predict the output from a series of electrical turbines, the electrical output. So the exercise is to compare a few machine learning models to find a way of predicting the right electrical output. So the first thing I did was I took the file and I checked what the file looked like. So that's the kind of data. Then I checked how many rows there are and performed a statistical analysis on the data. And I could see what the means are, what the standard deviation is, the minimum, maximum values, etc. against all of these variables in the data set. Then I check the correlation between the variables. So I can see that certain variables are negatively correlated, some are positively, but it's very small correlations positively here between relative humidity and ambient pressure, for example. Then I checked about created a linear regression model to predict the net hourly electrical energy output, which is the PE variable in the data set. And what I got was the R square of 93%, which means that the electrical output was, we've been 93% accurate in predicting what the output is. The mean square error is around 20. So it overshot the output by around 20 units per se. And for a given example, that was the output predicted. It assumed an input value. So as you can see, 14.96 for the average temperature, and so on and so forth. Then I try to create a plot of the linear regression model and highlight what the significant variables are. And as you can see, it is calculating that. And here we go. For example, it had a coefficient of minus 1.9859 for the average temperature in the equation. Obviously, there's an intercept there as well. The equation, I think I did plot, but effectively, these are the variables, these are the coefficients against those variables, and there is an intercept here, which is this one, constant value here. So it's 454 plus minus 1.99 times average temperature minus 0.23 times the vacuum value plus 0.06 of the average pressure minus 0.16 of the relative humidity would give you the output, electrical output, which is PE. That's the equation. Some graphs that show it. Again, R square value. Next, what I did, I tried to do the same thing with a polynomial model. So this is again scikit-learn, created the polynomial model. Again, the R square slightly improved from 93 to 93.8%. So we can be a bit more accurate in predicting the electrical output. So for that sample value that we used here, we got 466.36 as the predicted electrical output. Then I tried to write the equation for the polynomial regression performed above, and that's the equation with that intercept value. And this is interesting because it's negative intercept. That's very interesting. Which kind of says to us that if everything is zero, then we'll get negative energy produced, which is a bit obviously not right. Then finally, I tried the neural network to predict the output, and as you can see, it's tried to create a neural network with a hidden layer. That's the dimensions 150. Applied the activation function ReLU, use Adam, 500 iterations, it randomized the first state, and then the mean square actually slightly lower than what we could get using the polynomial prediction. So it's more or less same basically, and that's the value. So this is what I did for this exercise. Thank you.